Hello fellow calculus students, my name is Lucas Hicks and I am outside in the gazebo. So hopefully you can hear me, there's not too much wind, but let's do this math problem. It's on objective 97, problem number 6. It says evaluate the following integral using the fundamental theorem of calculus and then sketch the graph of the integrand and shade the region whose net area you have found. This is a fairly simple problem, actually, if you know the fundamental theorem of calculus. That's what we're given. The integral from -3 to 1 of x squared plus 2x minus 3x dx. Alright, so let's first look at the fundamental theorem of calculus, FTC. Oh, cord in the way. If f is continuous on the interval a to b, and f is any antiderivative of f, then the following equation is true, where you have the antiderivative of f of x, and then you have that antiderivative evaluated at b, and then you subtract that same antiderivative evaluated at a. Now, if you have trouble with remembering like antiderivative, derivative, and stuff like that, I made a little chart here to give a generalized idea of it. So you have f of x right there, which is the position function that you're given. And then if you were to take the antiderivative of that, that would, according to this theorem, it's capital F of x. And then you have the velocity, which is the derivative of f prime, and then acceleration is f double prime, and then jerk, which we haven't talked about, is f triple prime. And then that's also s of t, v of t, a of t. Now, technically, an antiderivative can also be going from acceleration to velocity, and then velocity to position. But just as a way of remembering it all, I put it together like this. So if this helps you, great. If it doesn't, just forget about it. Alright, so let's look at the problem. It's a little cold out here, so I'm a little shaky. I don't know why it's cold. It's supposed to be like summertime or spring or something. I don't know. So I basically took the antiderivative. That's what I did right there. End up with x cubed over 3 plus x squared minus 3x. And then I just evaluated that did that little bar thing, and that's -3 to 1, which is the integral we got. And so that has to be b minus a, so you keep in mind that you're doing the top one first minus that bottom one. That's very important. The easiest way to evaluate these, I found, was you could just figure it out in your head. This is pretty easy. Or if it's when you can't figure it out in your head, oh, hold on. Use the calculator and just enter it in on the y, plot that right there, and then do second table, do those points, and you get that. Now that gives you a decimal, so technically you would have to do the whole, go to second quit, and then do like the vars, and then go to the y thing, and then hit, this is hard to do with one hand, but you go to the function, type that in, hit enter, that gives you that, and then you can do the parenthesis, and then that point, which is 1, and then I'm afraid this piece of paper is going to blow away. There we go. And then hit enter, and then do math, enter, -5 over 3. So that gives you the same thing. This one is pretty easy, so I just kind of figured it out myself. -5 over 3, and remember to subtract that by the second one. Don't add it, subtract it. Figure it out, and that gives you -32 over 3. That is the correct answer because I plugged it into the computer and it was correct. Awesome. I forgot to mention that is the area. That number is the area of that function. So that shaded in area equals -32 over 3. Sorry about that. So the second part, it says, now sketch the graph of the integrand and shade in the region whose net area you have found. I did this on, alright, I got this thing pulled up. It wasn't coming up before, but now it is. There's that function, the original function, not the antiderivative, but the original function, from that point there, the -3 to 1, and that's the shaded area that we would get. So that's this problem, and I think I did it in 5 minutes. Hope you enjoyed it. Hope you enjoyed this wonderful weather we're having out here. Let's see if I can get a little bit on my face. There we go. Thank you very much, and peace out.